Hi guys, I want to tell you a little bit about assignment two, part two, in case you're having some troubles with that, and give you some examples of what to go from on that. Again, happy to meet with anybody that might have a question or two that would be easier to answer in person via Zoom meeting. So just reach out via email, and we can get that set up. So I've got couple slides here to show you to share that piece. So again, this is just some quick overview and some ideas for assignment two, part two. So if we were in a help session, these are some of the things I would have shared with you. So you need to decide whether or not you're looking at coastal erosion or river erosion processes, and maybe look through the lecture notes on that, as well as the chapter readings associated with those processes. So pick one of those ones, and that's what you're going to do your 3 or 4 or more plan view sketches on. Then on each of your sketches, you need to make sure you included the key map elements that I'm asking you to have on those sketches. So that's a title, and part of that title will probably also be a time frame piece. So whether you're from like your overview picture of longshore drift just starting in 2020, and then your next one is maybe 2080, and the next one's maybe 2130, depending on what your time range is. Then you're going to include a scale. I just want you to include a fractional scale. So that's like the 1 to 50,000 is an example of a fractional scale. But as a thing to keep in mind, 50,000 is 1 to 50,000 is not a reasonable fractional scale that you would want to use for your sketches. If you think about it, the map we use for part one, we see a ton of information, but not a lot of detail. And if we want to see something that's taking place on the scale of, you know, a meter to a couple of meters over 10, 20, 30, 40 years, we probably need a scale that has a smaller number than 50,000. So I would say, and I've said this in a couple of help sessions, that anywhere between sort of 1 to 8,000 up to 1 to 12,000 or 1 to 20,000 would probably be reasonable. And again, I'm happy to chat with any of you about that. You need to add a north arrow. It's totally up to you where north is. You need to have a legend. So some things to have in that legend might be colors. If you have like water, or maybe you have beach material. There's some symbols that we saw in part one that show us things like how you would describe a rocky ledge or a cliff. And then you also need to, maybe it might not be appropriate for all of your maps, but for most maps, I think it'd be appropriate to include spot elevations. So that's like a benchmark. And so we saw that in part one when we were trying to find the elevation for City Hall. We found that 315 benchmark. So benchmark is something that wouldn't be part of a contour line, so it doesn't end in a 0 as an example. And you don't need to draw any contour lines. We use computers to do that now, so and that's just gonna be too much on your scans that you're gonna submit. And then again, that final reminder that this is like looking from above. So if you were thinking about doing coastal erosion that shows going from like a cave to an arch to a stack to a stump, that's a really good thing to do for an oblique view or a side view. But if you're looking at it from above, it doesn't, as the cave and the arch is forming, you're not actually seeing any changes. So that doesn't really describe, or doesn't really hit what I want you to hit with this assignment. So you would have, one map that stays the same, and I want you to show me a plan view of coastal erosion if that was the topic you chose. So again, to give you some ideas about those, what you might do. So for coastal erosion, you could do cliff erosion. So that's similar to what we saw in that video on Pacifica, California, where they had that drone flying across and those houses were falling in. And again, you could look up some work on Pacifica, California to find the average rates for that, to sort of decide how much time you need to have between each of your sketches. Another one would be like longshore or littoral or beach drift, and showing that over time. So as an example of what that might look like, and I'm just going to show you what like longshore drift might look like. We drew this in class. We also drew that cliff erosion one when we were talking about how wave refraction impacts a headland as it's coming in. So I'm going to have my, this is going to be sort of my edge here. This is a bit of a rough drawing here, so I'm doing it live. And maybe I'm going to have a symbol here. These little dots are going to represent beach material. So this might be step one, as I have a beach kind of covering all of this area over here, but I'm going to use dots to show that instead of scribbles, but I'm trying to get this done quickly so the video isn't 45 minutes long. Let's see if I can change my pen color. Then I'm going to maybe color some things in here and have like show that this is all water. Whoops, that water got a little bit crazy. So that's like my step one map. In my next map, and again, I'm just gonna add on to the map that I'm showing you right now, instead of erasing and drawing a new one. So in my next step, and I think I got a different color pen, maybe what I'm gonna actually show is that my beach, and instead of coloring it in, I'm just gonna sort of outline it here, that my beach has actually got some erosion happening here. And so instead of my beach being all the way out here like it was in my first time map, it's actually almost all gone along here. So showing that beach erosion. And then maybe in my step 3 map, maybe this map's gonna have 4 pieces. Maybe the people that live or use this beach have built a groin here on our beach, and that groin has resulted in sediment accumulating along one side, sort of to show that the impact of that groin is that now I have all of this beach. It's sort of coming out all the way up to here. Oh, I'm going to add another groin to make this a little bit better here. Put another groin down here. So in this case here, pink or that magenta color, if you're picking on my pen color bar, is going to show me the accumulation of sediment along the groin here. So majority of the sediment is accumulating through here and getting stuck here. And then again, not much sediment down here, but maybe there's another groin off my picture where all that sediment is showing. So that's showing sort of evolution of longshore drift along this area. And that's, again, good example to demonstrate that you understand how longshore drift or coastal erosion might work. For an example for river erosion, and again, we've talked about this a couple of times in class, and we've talked about this in other help sessions, so if this may seem familiar to you, I'm going to get my pen color back to blue here. So maybe I'm going to sort of show a series, maybe 3, maybe 4 plan views of a river system. So just to start off simply, here's my river, sort of looking a little bit crazy on that one corner there. Fix that. Comes around like this. So here's my river, and I would maybe show with an arrow water directions. Maybe I would have some point elevations in some places. That seems like a lot for point elevations. Maybe I would show that there's some sediment in the water here. And again, I'm not going to change my pen color because I'm going to make my pen color differences be the differences in terms of time frames. So my step 1 is this blue line that I'm showing here. And again, the sediment is accumulating on my point bars. And then maybe on my cut banks, I might show some cliff erosion, and I might need to invent a symbol for that sort of cut bank erosion. But that's where that cut bank is. This is the cut bank here. This one kind of has a funky corner here. So that's what we've got happening. So over time, and my next color I'm going to pick here is going to be red. Over time, my that cut bank is going to cut out further, and that point bar is going to migrate across. So in whatever my time frame is going to be, maybe this is now what my channel looks like, the red line. So exaggerating, that point bar has come across here. This one's maybe looped around like this. It's a big time frame here. And then this is cutting across. That didn't cut that much. And then again, my red line on top of that, this is coming around like this. And then things are getting kind of funky in this one corner here. Maybe you can see you can guess what's going to happen at that point. Do my labels. I'd have my benchmarks, that kind of thing. I would include another arrow here showing what's happening. And again, my point bar has that accumulation piece. So that in my next drawing, maybe what's going to happen, for my next drawing here, we'll do green pen. My next drawing here, maybe what happens is this gets cut off. So this now goes across like this. This comes across like this piece here. So now my whole system kind of looks like this, and sort of a straight channel at the bottom down here. Join this guy up. It doesn't have to be right on that red line, but just sort of following along like this. And maybe now out here, I have a new oxbow lake as that example. Here's my Oxbow Lake sort of filling into this area here. Maybe I have some other things to put on my symbols. So I have that marshy stuff happening in some of these places. So some marsh happening here in this map. One of the things people have asked about, so again, that's what in 3 drawings, I could do it in 3 or 4 drawings. That's what bank erosion might look like. Some people have asked about what would be a good reference for these things. So as an example, in the coastal erosion piece, we were talking about Pacifica. There's some other ones we looked at in class. I think a good reference for that, the rate of bank erosion, if you go into Google Scholar and you type in river space bank space erosion, one of the first papers that comes up is a paper from the 1980s by Dr. Janet Hook. And it's a pretty simple, really straightforward paper of example of bank erosion in the UK. So I'd recommend that you check out that one as a reference. I think it's really easily readable, and I think also the measurements make sense. There's more than that for sure. It just was something that we were looking at last Friday. A lot of people found that Hook paper. So Hooke is her last name. And again, it's a pretty seminal paper, pretty important. And it gives you kind of a range of the rates of bank erosion that you could use to determine the time steps between each of your maps. And so, yeah, that's that's sort of the quick tutorial about part 2. If you have any questions, like I said, please contact me via Zoom or email, and we can set up an appointment to chat in person. I'm happy to look at something that you maybe have sketched out. We can look at that quickly through screen sharing, or you can just like hold up your picture to the camera. All right, guys, take care. Bye.